Hello colleagues, today we will try to solve the medium problem called max increase to keep city skyline with JavaScript. My name is Alexander Zelenin. I'm a software engineer with more than 15 years of experience. The plan for today is next. First, we will go through problem and observe the requirements. Second, we will design an algorithm. Third, we will calculate complexity of this algorithm and try to find how to optimize it. Fourth, we will write the code itself. And fifth, we will test that everything is fine and see what findings we have after all of this. So the link to the problem is in the description, so take a look. I will not read the full task. I read it right before starting this stream, so I will explain by my own. So set pause on recording if you want to read. We have something like a map view from top to the city. And this represented by the two-dimensional array. Every number represents the height of building on this cell. The 0 is still height of the building, so it still counts as building. And we can increase height of every building by any number. But we need to keep one rule. We want to make city looks the same from every side. So like if we take a look from left to right, we can find the highest buildings as 8, 7, 6 and 3. So this will be highest building. So from the left, other buildings can have a maximum of this height. If we will take a look from the, I think it would better tell not from left or from right, but from east to west and from west to east. If we will take a look from south, then we will need to maintain like the maximum height from the columns. So it will be like 9, 4, 6 and 7. So let me try to move this one into the best design tool ever. And let's see what we can have here. So I will just remove these ones to make it like this. So we can increase this the height of every building. Maybe a smaller one, yeah, like this. No, yep. And if we take a look from the west to east, from the east. Okay, I always forgot the names of. So we want to find the highest numbers from this side, which is these ones. And we will able to increase other numbers up to this value. So all of these buildings are lower than these ones. So we sorry, here we have 9. We have 9 and not 6. My mistake. We have these highest buildings, and that means that we can increase high of other ones up to like this one up to 8, this one up to 8, this one up to 7 and so on. But we need to maintain a rule, as I told previously. So let me just to do it again. 9, 3, 7, 8. We need to take a look at city from different direction. Let me use another color, yeah, like this. So when we keep looking from this direction, we also can see that different numbers represent the ways. So if we take a look from this side, we have 9, 4, 6, and 7. And for every building, we will need to take a look at the corresponding numbers from each side. So for 3, we'll take a look for both of them, and we'll go for 8, since 8 is the smallest one. And if we will go for 9, from left side, we will change the look of our city. So for example, for 5, we will need to compare for all numbers we have here in meaning of vertical ones. We will go for 9, right? Yep. And for horizontal one, it will be 7. So this one will go to 7, for example. Let me just took a few more examples. So for these two, if we go look from down to top, we have 4 here, and on the line we have 9 here. 4 is smaller, so this one will be 4. Generally speaking, in this task, in this example itself, we have something like an answer. So we have explanation how we reach the state, and it was offered like if we see from top to bottom, we have 9, 4, H7. If we see from left to right, we have H7, 9, 3. So as for me, this idea looks really good to prepare the 2 such arrays, and then go one more time through all elements in the city and change them to proper value. So let's try to calculate complexity of this approach. So first step will be to let me just make it smaller like this. So the first step is to get highest buildings. In row and columns. Second, go through all buildings and compare. And compare with the smallest one. So what will be complexity of each step? So first of them is get highest building in a row. How we can do this? We will go through every row and just find out the largest number and put this number in a new array. So we're creating an array, we put 8 here since it's the largest one. Then we go to next one, we go through every element, we find out that 7 is the largest one, and so on. So for the second step, not the second step, but to find the columns, we can do something like that, but in verticals. Originally we can do this maybe in one run, but that's fine. I think yes, we can do this in one run. Maybe it will be better. So we go from both of them. We fill two arrays, and like in best case, we just go through every element once. So the complexity of the first step will be on. In the case of time complexity is how CPU usage change depending on incoming variables. So for example, if we have 16 items here and we need to do 16 operations, so complexity is the same to count of operation, and complexity will be on. And we need to see our memory complexity, space complexity. Space complexity is the same, but like for memory. How many additional space we will need to use to perform our algorithm. We store just two additional arrays, and every of this array represent one column and one row of the city. So it will be less than elements of array. Originally it will be so if we have 4 and 4, 8. In this case it will be like half, but okay, it will be not more than n anyway. For example, if we will have the smallest city of just 4 elements, we will store all of them, so we end up with on. And the second step, we again second time go through all buildings and like try to increase the size and count what the numbers we have right now. This will also took on, so we have total like 2n, but we can drop constants since they are meaningless in means of algorithms. I'm not sure that we can optimize it anyhow. At least from algorithm complexity, we will end up with something like that. It's possible to do it without additional memory usage by finding the highest and highest element in like every time for every row and column, but in this case we will increase our complexity to n square, which I want to avoid. So I feel that this one looks promising, so we can go to next step and try to implement our code. Let's just take a look what conditions we have. The count of grid length. What is grid? Okay. The count of rows and columns is from 2 to 50. And height of every row or column in range from 0 to 100. All buildings occupy the entry cell. So yeah. Okay. So we can try to go with writing code and see what we will have here. So I hope everything is visible. Oh, I forgot to run chat today, but not sure if anyone writing. Sorry if you had right and I not answer. We'll try to do better next time. So we have grid, and we will need to find out like row and column. we can start with creating arrays for both of them. So like row max heights will be array of grid length elements. Then we create col max heights, same, creating array of grid length elements. Then we will go through grid. We can make it with for each, I think. For each, we'll have the row itself and row index. Inside we will have the same cycle, but for row itself. For each column and col index. So we go through all the elements, and in the end we need to return how many total additional floors we have. So let's create variable additional floors, which will be initially 0, and we can return it additional floors. Okay, so we will add additional floors on next steps. Let me add few rows. I like when you, an editor, can like scroll down after the last lines, because otherwise it makes me a bit uncomfortable. So okay, we need to compare our current item with row and columns and see and modify it if our like new one is higher. Also, this one will be not column but height already, because second number represent already height of the building itself. So like this one, so it will be 3, 0, and so on. But the row itself, it represent like whole row. Okay. So we will compare if height is greater than row max height, row index, and if so, we will assign to the row index this height. And we'll do the same, but for the column. So we have column, and we will use column index. So for example, we're starting with 3. Initially we have empty array, so 3 will be higher than anything. So we're starting with, let me use another color. We're starting with array of like 3, 3. Then we go to 0, and 0 will compare first for the row index. Row index doesn't change, so it will compare with 3. 0 is not higher than 3, so it doesn't change it. For next value, we compare it with like we doesn't have any value for the second one, so here we will have 0. For third value, we have 8. 8 is higher than 3, so we write 8 here, and we write 8 in second one. We go for the last one, 4. 4 is less than 8. We doesn't change this one, but modify this one. Okay. So then we go for the next line. We have 2. We write down 2 here. We compare 2 with 3. 2 less than 3, so we doesn't modify the second array. We go for 4. 4 is higher than 2, so we rewrite it. No, sorry, 1 second. Let me... Yes, all right. So we have 4. We compare 4 with 0, it's also higher, so we have 4, 4. Then we have 5, we write 5 here, but 5 is not higher than 8, so we don't modify this one. Then we go for 7, 7 here and 7 here. Sorry for a bit mess, but I hope you understand the way of how it works. So after all of this, we have like all heights and so on, and we can go through our grid one more time. I presume that it's possible somehow to do it with one run, but it will not change complexity itself anyway, since we drop constants and this is just on. So we will compare the current height with so we have these two values, this one and this one, and we will took the minimum of them. So we have function called math min, which return minimum value, and we can assign it to just max height. So const max height. This will be a max height for the current building. And now we can increase our additional floors by the difference between current high and max high. Sorry, max high minus current high. So for example, if we have 8 minus 3 will give us 5. So we add 5 floors. What is important, we don't need to modify our array itself, because it's like useless operation. It will doesn't change anything. We maybe can do some like some optimizations by modifying like the previous columns and so on to some value, but I am not sure that it will be like best flow. So first, what we need to solve the task properly. So I think we can try to run our code and see how it will work. So let me just zoom out a bit to get buttons. So let's run code. Max high is not defined. I just make a typo. So our output is wrong. We return the none. Okay, we have an error. What we need to do in this case? First, what I will do is I will try to find out what we have inside the row max height and col max height after we going through cycle. So we can add the console log and display both of these arrays and see what they contain inside them. So we have empty items in every of them. Like, okay, let's try to understand why we have empty items. We had to compare the height of current building with empty. Maybe the problem here that okay, we can go to console and can I zoom in here? Unfortunately, I cannot zoom in here, but I will try to explain verbally. So if we have, for example, value of 5 and undefined, and we try to compare 5 and undefined, and 5 is not greater than undefined. So the problem here is we cannot compare like this. We need to check that value exists or to fill array with some values. Unfortunately, I didn't remember is there some function to fill array with 1 second. Yep, we have a function called fill, and we can write something like this. So, and in this case, in this case we fill our array with 0 values, so everything worked fine. So the first problem was that the array doesn't have any values, and we was not able to compare with undefined. Originally I had presumed that we can compare the number with undefined, and number usually should be higher. But okay, that's some JavaScript magic that I forgot a bit. So we fill our array, it works fine. Let's try to submit our code and see what we will have here. So we have runtime of 72 milliseconds. We have success. Looks like our solution is fast enough. At least it's faster than like from other people who try to solve it. So we solve it. Nice. So let's go through our code and see what complexity here we have for every row. So space complexity, time complexity. Set video on pause and try to calculate it by yourself. So for the creating and filling array, we also have something like on. We have on for okay, first I go with the space complexity. Both of this array will be up to on. Originally it will be up to on divided by something, or it's not divided, it will be like a squared of n, and this one will be also same as squared n. Maybe this will be like the proper representation, but I didn't remember, is it matter anything squared? Maybe it I forgot what to do with roots of numbers. So but originally we have like memory consumptions of square root of number itself. Okay, and for this variable we have just one. We doesn't store anything else, we doesn't have any additional structure. Okay, we have max height, but it's temporary and it's also 1. So space complexity will be O squared n. I didn't remember, do we need to keep the root or not? So initial was wrong, we have even better complexity of square root of n, which is nice. And time complexity. For time complexity, let's also go through all elements and see what we have. So first we are filling our arrays with zeros, and this also will take a squared of n. So this will be the same for the time complexity. Since we're going one by one, insert 0 and so on. This will have just one, since it's just assigning variable. For the grid itself, we'll have space time complexity of n, since we go through every element. And inside there is just comparison, so all of inside is just 1. So we have on for this cycle, and we have on for this cycle. Math mean is 1, this is 1, so we doesn't have anything else. So we have total time complexity of something like O2 squared to n plus 2n. So can you guess what we can drop from here? So first, you know that we can drop constants, so it will be like that. And second thing, that we can drop meaningless part. This one will be meaningless since we already have n. So we will end up with complexity like on. We can drop this one since it's significantly smaller than just n. That's the idea behind calculating complexity. So, what we had learned today? First of all, we solved the task. We're in good shape. Second, if there are some problems and some unexpected things, first check data you're working with. In this case, there was 2 arrays we created, so we check them and see them that they are empty, and that is unexpected behavior. So this was the first thing where we try to look at. Sometimes complexity is better than you presume initially, because you might thinking differently. So it can differ. That's the reason why we calculating it 2 times. First to design algorithm, and second to check. So I think this task go easy enough. Set like, subscribe, and if today this video will get 5 likes, tomorrow we'll solve the hard problem and not medium one. So see you tomorrow. Have a nice day.